Hi guys, today I'll be teaching you how to evaluate a circuit. So I have given you a problem here and it asks you to find the total R equivalent I1, I2, I3, VR1, VR2, VR3, PR1, PR2, PR3 and P total. So go ahead and pause the video and try to solve the problem. Okay, so first to solve this problem we'll find the R equivalent first so that we can find the rest of the values. So in order to find the R equivalent, what you need to do is you need to first break up the circuit. So when solving for a R equivalent, you should come like away from the battery and then you should work your way toward the battery. So first what we need to do is we need to make these two resistors as one resistor and we need to combine them and get the total resistance for that. Okay, so if for these two resistors the total R resistance value will be 1 by R equals to 1 by 50 plus 1 by 50. Now if we simplify that, we will get 1 by 25, and if we get for R, we will get 25 ohms. So if we combine these two resistors, then we will get 25 ohms. Okay, next we need to get these two resistors here, this one and this one, and we need to combine them to get the total R equivalent. So if we do that, what we'll next get is you will get a total of 55 ohms by adding up these two resistance values. So if we add them up, we will get 20 ohms plus 25 ohms, and that will be 45 ohms. So the total R equivalent will be 45 ohms. Okay, so now we have solved for the first part in the problem. So now for the second part, we need to find I1. So if we need to do that, basically I1 is the entering current from the battery. So in order to find I1, what we will be needing to do is do VBAT divided by the total R equivalent. And now if we do that, what we'll get is 180 volts divided by 45 ohms. And now if we simplify that, we will get a total of 4 amps. So now we have found I1. Now let's find I2. So to find I2, since resistors in parallel have the same resistance values, what we'll need to what we'll have to do is the current here will get split across them equally since they have the same resistance values. So now I2 will be 2 amps since 4 divided by 2 is 2, and I3 will be 2 amps too. So we have solved I2 and I3. Okay, now what we'll be doing is we'll find VR1. Now to find VR1, what we'll need to do is we need to do I1 times R1. Now for I1, what we have found is 4 amps. So it'll be 4 times the resistance value for 1, which is 20 ohms right here. So it'll be 4 times 20, which will go as 80 volts. So we have found VR1. Now to find VR2, it's basically the same steps again. We will do I2 times R2. Now R2 has a value of 50 ohms and I2 has a value of 2 amps. So if we evaluate that, we will get 100 volts. Now for VR3, what we'll do is we'll do I3 times R3, and for that R3, for R3 we have 50 ohms, and we have a total of 2 amps for that, so it'll also be 100 volts. So now we have found VR1, VR2, and VR3. Now what we'll be doing is we'll find PR1, PR2, PR3, and P total. So to find the PR1, what we'll be doing is we need to do I1 times voltage VR1. Now the values for that are 80 volts times 4 amps. Now that'll be a total of 320 watts. Now for PR2, it's basically same steps again. What we'll be doing is I2 times VR2, which will then be equal to a total of 2 times 100, which is 200 watts. Now for PR3, it's the same steps again. It'll be I3 times VR3, and I3 is 2 amps and VR3 is 100 volts. So if we simplify this, we will get, one second, for VR3, okay, so let me read it again. So for I3 it was 2 amps, and for VR3 it was 100 volts. So it'll be 200 watts again. Now in the problem, the last step we need to do is find P total. Now to find P total, it's just simple. We need to add up these 3 values here, and we will get a P total. So it'll be 320 watts plus 200 watts plus 200 watts. Now this will be a total of 720 watts. So now we have found all of the values that are asked in the problem.